20,000 Leagues Under the Sea, Chapter 13. Some figures. A moment later, we were seated on a sofa in the lounge, smoking cigars. The captain handed me a diagram of the Nautilus showing cross-sections and side views. He then began to describe the ship as follows. Now, Monsieur Aronnax, here are the various dimensions of the ship you're on. It's in the shape of a very elongated cylinder with conical ends, rather like a cigar. This shape has already been used in London in several ships of the same sort. This cylinder is exactly 230 feet long from stem to stern, and its beam at the widest point is 26 feet. It is therefore not built exactly in the ratio of 10 to 1, as with your fast steamers, but its lines are sufficiently long and curved so that the displaced water moves away easily and acts as no obstacle. These two dimensions will enable you, by a simple calculation, to obtain the surface and volume of the Nautilus. It has a surface area of 10,885 square feet and a volume of 52,980 cubic feet, which means that when it is entirely submerged, it displaces 52,980 cubic feet of water, or in other words, 1,657.9 tons. When I laid my plans for a ship destined to sail beneath the surface, I wanted it, when at a state of equilibrium in the water, to be 9/10 submerged and only 1/10 above the surface. Consequently, its ratio of weight to volume had to be 9 to 10, or, in other words, it had to weigh 1,492.13 tons. I therefore had to be careful not to exceed this weight while having it built to the aforementioned dimensions. The Nautilus has two hulls, one inside the other, and joined together by T-shaped irons, thus giving the ship great strength, and thanks to its cellular arrangement, it has the resistance of a solid mass. Its size cannot give way. They adhere to the ship by themselves, without their rivets, and the homogeneity of its construction, achieved by the perfect union of the materials involved, permits it to defy the most violent seas. These two hulls are made out of steel plates whose density is 7 8/10 that of water. The first of these is no less than 2 inches thick and weighs 434.46 tons. The second hull, along with the keel, which is 20 inches high and 10 inches wide, and alone weighs 68 tons. The engine, the ballast, the various accessories and furnishings, the bulkheads, and inside braces all weigh 1,057.67 tons, which added to the 434.46 of the first hull make the required total of 1,492.13 tons. Do you follow me? Yes, I answered. Therefore, continued the captain, when the Nautilus is floating, 1/10 of it is above water. Now, if I have reservoirs with a capacity equal to this 10th, or in other words, of 165.79 tons, and fill them with water, the boat would then weigh 1,657.9 tons and would be completely submerged. And this is exactly what happens, Professor. I have just such reservoirs aboard in the lower parts of the Nautilus. I open some cocks, water enters, and the boat sinks just below the surface. Yes, Captain. But now we come to the real problem. I understand how you can go just below the surface, but as you go deeper below this point, won't your submarine encounter a pressure and therefore a force pushing it upward equal to 1 atmosphere for every 32 feet of water, or almost 15 pounds per square inch? That's right, monsieur. So unless you fill the Nautilus completely, I don't see how you can make it dive down to great depths. Professor, replied Captain Nemo, you must not confuse static and dynamic situations, or you will fall into serious errors. It requires very little effort to attain the great depths of the ocean, for an object develops a sinking tendency. Please follow my reasoning. I'm listening, Captain. When I wanted to calculate the increase in weight I had to give the Nautilus in order to dive, I only had to concern myself with the greater density of water at increasingly lower depths. That much is evident, I said. Now, although water is not absolutely incompressible, it is at least compressible only to a very small degree. As a matter of fact, according to the latest calculations, this reduction in volume amounts to no more than a proportion of 0.0000436 per atmosphere, or for each 32 feet of depth. So if I want to go down to a depth of 3,200 feet, I take into account the reduction in volume at a pressure equivalent to that of a column of water 3,200 feet high, or, in other words, a pressure of 100 atmospheres. The reduction in volume would therefore be 0.00436. Hence, I must increase the weight of the ship to 1,665.14 tons instead of 1,657.9 tons. Or, in other words, an increase of 7.24 tons. No more than that? No more than that, Monsieur Aronnax. And these figures are easy to check, but I have supplementary reservoirs capable of taking on 100 tons. I can therefore go down to considerable depths. When I want to come back to the surface, I have only to get rid of this water and empty all the reservoirs. And then the Nautilus will again emerge by 1/10 of its total height. To these arguments, based on figures, I could raise no objection. I cannot argue with your calculations, Captain, I answered, and moreover, it would be rather ridiculous to do so, since daily experience has proved you right. But I foresee one very real problem. And what is that, monsieur? When you go down to a depth of 3,200 feet, the Nautilus's hull sustains a pressure of 100 atmospheres. If at that moment you want to empty the supplementary reservoirs in order to lighten your ship and permit it to rise to the surface, your pumps must overcome this pressure of 100 atmosphere, which is equal to 1,470 pounds per square inch. That would require a force that could only be supplied by electricity, Captain Nemo quickly interjected. I repeat, monsieur, that the dynamic power of my engines is almost infinite. The Nautilus's pumps have prodigious force, as you were able to see when they threw torrents of water over the Abraham Lincoln. Besides, I only use those supplementary reservoirs to attain depths between 5,000 and 6,500 feet, and that with a view to sparing my machinery. But when I decide to visit the deepest parts of the ocean, 6 or 8 miles below the surface, I use slower but no less infallible means. What are they, Captain? But this brings me naturally to an explanation of how the Nautilus is maneuvered. I am very anxious to learn how this is done. In order to steer this ship to starboard or to port, in order to maneuver in a word, horizontally, let me start this paragraph over. In order to steer this ship to starboard or to port, in order to maneuver in a word, horizontally, I use an ordinary rudder with a large afterpiece affixed to the rear of the stern post, operated by a wheel and pulley tackle, but I can also move the Nautilus up and down by means of 2 fins attached to the side of the ship at the center of gravity. They're completely movable and are operated from inside by means of powerful levers. As long as these fins are held parallel to the boat, it moves horizontally. When they're placed at an angle, the Nautilus, according to the degree of this angle and the speed at which it is traveling, dives or rises as steeply or gently as I wish. And if I want to rise even more quickly, I merely disengage the propeller, and water pressure makes the Nautilus rise vertically like a hydrogen balloon going straight up into the air. Bravo, Captain, I cried. But now how can the helmsman follow the course you've given him underwater? The helmsman is inside a special compartment that juts out the top of the hull, which is equipped with lens-like windows. You have glass that can stand up under such pressures? Absolutely. It's fragile when it's hit, but it's nevertheless very strong. In some experiments made with fishing by electric light in 1864 in the middle of the North Sea, glass plates only 9/32 of an inch thick were found capable of withstanding a pressure of 16 atmospheres and at the same time permitting powerful heat rays to penetrate them. Now the lenses I use are more than 8 inches thick at their centers, or in other words, about 30 times thicker. Granted, Captain Nemo, but in order to see, some light has to pierce the darkness, and I wonder how in the midst of the black depths. Behind the helmsman compartment, there is a powerful electric light whose rays illuminate the water for half a mile around. Bravo, bravo, Captain. That explains the so-called narwhal's phosphorescence, which so intrigued scientists. While we're on this subject, I would like to ask you if the collision of the Nautilus with the Scotia, which caused such a stir, was accidental. Completely accidental, monsieur. I was cruising 6 feet below the surface when the collision took place. Besides, I was able to see that the damage was not really serious. No, monsieur, it wasn't. But as for your encounter with the Abraham Lincoln... Professor, I'm sorry for one of the finest ships in the American Navy. But I was being attacked, and I had to defend myself. Even then, all I did was put the frigate in a position where it could do me no more harm. She will have little trouble repairing her damages in the nearest port." "Ah, Commander," I cried enthusiastically, "your Nautilus is truly an extraordinary ship." "Yes," Captain Nemo replied with genuine emotion, "and I love it as if it were my own flesh and blood. In one of your ships, sailing amid the hazards of the ocean, everything seems fraught with danger. In traveling on the surface of the seas, one's first thoughts are about the abyss below, as the Dutchman Janssen so well put it. But on the Nautilus, one has nothing to fear. The hull itself is untouchable, for it has the rigidity of iron. There's no rigging to be harmed by rolling or pitching, no sails to be carried off by the wind, no boilers to be torn open by steam, no fear of fire, since the ship is made of steel, not wood. No coal supply which can run short, since I run the ship on electricity. No chance encounter to fear, since I'm alone in sailing deep water. No storms to ride out, since several yards below the surface reigns absolute peace. There, monsieur, a ship to end all ships. And if it's true that the designer has more confidence in a boat than the builder, and the builder more than the captain, then you can understand how great is my trust in the Nautilus, since I am its captain, builder, and designer all in one." Captain Nemo spoke with an infectious eloquence. He seemed transformed by the fire in his eyes and his impassioned gestures. Yes, he loved his ship as a father loves his child. But one perhaps indiscreet question naturally came to mind, and I could not help asking him. "Are you then also a nautical engineer, Captain Nemo?" "Yes, Professor," he answered. "I studied in London, Paris, and New York when I was still an inhabitant of dry land." "But how were you able to construct this marvelous Nautilus in secret?" "Every part of it, Monsieur Aronnax, was sent to me from a different part of the globe and to a disguised address. Its keel was forged by Crousot, its propeller shaft by Penn and Company in London, the steel plates of the hull by Leard in Liverpool, its propeller by Scott in Glasgow. Its reservoirs were built by Cale and Company in Paris, its engines by Krupp in Prussia, the spur on its bow in the Metalla workshops in Sweden, its precision instruments by Hart Brothers in New York, etc. And each of these companies received my plans under different names." "But after these various sections were made," I answered, "they had to be assembled and put in place." "Professor, I set up a workshop on a desert island in mid-ocean. There my workers, or rather my companions, whom I taught and educated, helped me complete the Nautilus. Then when it was finished, fire destroyed all trace of our stay on the island, which I would have blown up had it been possible." "But this boat must have cost a fortune." "An iron ship costs $225 per ton, Monsieur Aronnax. Now the Nautilus weighs almost 1,500 tons. It therefore cost $337,500, or $400,000 with all its furnishings, or close to $1 million counting the works of art and other collections it contains." "One last question, Captain Nemo." "Go ahead, Professor." "You must therefore be a very rich man." "Infinitely rich, monsieur, and I could easily pay France's $2 billion debt." I stared fixedly at the strange person telling me these things. Was he taking advantage of my credulity? The future would tell me.